For over 6 years, it was one of the best-kept secrets in motorcycling. A Harley that was unlike anything Harley had ever built. When it was finally unveiled in the summer of 2001, the new bike came with a long list of firsts. Harley's first liquid-cooled engine, its first exposed steel and aluminum body, the first Harley to do 115 horsepower straight out of the box. They called it the V-Rod. It all started with the idea of doing something that had never been done before. For almost 100 years, Harley-Davidson had put out some of the most classic motorcycles ever built. In many ways, they became a symbol of the American spirit itself. By the 1990s, Harleys were so popular that you needed to be on a waiting list just to buy one. Despite this success, Harley was losing ground to a new generation of riders, more interested in speed than in style. At a meeting of Harley's Product Development Committee, the idea began to take shape. Was it possible to combine the best of both worlds? The speed and power of a performance bike wrapped up in a style that was unmistakably Harley. The top secret project was codenamed P4.
We were really interested in reaching out to an even broader base of customers.
Everybody had their own concept on what this thing was going to be, but we knew what the essence of this motorcycle was going to be. You know, bare bones, powerful, custom. To get the performance we wanted and the acceleration we wanted and all the things we wanted out of this motorcycle, we realized we had to do something new.
To find that something new, they turned to Harley's Superbike racing team, which had spent years building and perfecting its own radical racing engine, the VR1000. Until now, every stock engine Harley had ever put on a bike had been air-cooled. The racing team's VR1000 was liquid-cooled, which meant it could rev higher and go faster, and that was just the beginning.
It had dual overhead cams. It had 4 valves per cylinder. It was a dramatic departure from our heritage.
And all of a sudden, we're getting into this new territory, and the challenge we're facing is, you know, how do we keep the allegiance of our tried and true customer?
Until you've been on a Harley-Davidson, you haven't been on a motorcycle.
Harley owners, for all their colorful lifestyles, are quite possibly the most loyal customers of any product anywhere.
The biggest risk in this project from the beginning was how could we make a bike that would perform differently and be a very different type of motorcycle, but one that still says, I'm a Harley.
When you saw it going down the street, it had to scream Harley-Davidson. When you heard it, it had to say Harley-Davidson.
To pull this off, the P4 project was turned over to Harley's styling department, led by the legendary Willie G. Davidson.
In order to keep this bike a Harley, it had to have the Willie G touch. And that's something magic that we have, that nobody else has, that's a cornerstone of this company.
We don't often have the opportunity of concepting an entire motorcycle, but this time we can really get into the details.
Grandson of one of the founders, Willie G. left Milwaukee in the late 1950s to go to design school in California. In 1963, the prodigal son returned to become Harley's first VP of styling, where he proceeded to light a fire under the idea of what a Harley was supposed to look like.
Low and long and lean.
In the 60s, many Harley owners were turning their bikes into customized works of art.
Now what have we here?
Instead of being offended that the company's bikes were being chopped apart, Willie G. was inspired. He went back to Milwaukee to create the Super Glide, the Lowrider, and a whole new style of bikes that came to be called factory customs. It was a move that helped launch Harley-Davidson from the brink of bankruptcy to unprecedented success. And for the next quarter century, he personally oversaw the design of every new model Harley turned out.
That gives it a forward motion, and it really borrows from dragsters visually, which I think are very exciting.
In the summer of 1995, Willie G and his team of stylists took on Harley's greatest challenge ever, designing a brand new motorcycle from the ground up.
This long front end is going to give the bike a side profile that will be very recognizable.
If we don't get the frame right, the body won't follow. We have to get the frame right first. But we have to have some sense of where the body wants to be so that we can do the frame.
But I wanted this vehicle to have that type of presence where you'd walk up to it and you say, that's a new Harley-Davidson. Wow.
Since speed was a key design element, the team found inspiration in another kind of racing bike, dragsters. Louis Netz had been Willie's second in command since the late 70s.
Drag racing motorcycles have a certain feel to them that's very low and long, aggressive, minimal. So then that starts to create a sense of direction.
When you consider the amount of real estate looking at the side profile and the impact.
Kirk Rasmussen was brought on board to transform the ideas and sketches into three-dimensional computer-aided designs.
So we'll be seeing this in 3D, and there's some interesting things going on from a side view.
The youngest member of the team, Frank Savage, had joined the styling department just a few months earlier. He would cut his teeth on a project that every young designer in America could only wish for.
This simulates more of the rake of the vehicle.
It looks fast.
Right.
That's great.
It does.
It's good. Make a call. That was just so exciting that I could be at the ground level of this thing and watch it rise. Just a dream come true. I mean, you could try a lifetime to get into a project like this and it wouldn't happen.
Early on, they came up with their own nickname for the P4, Digger.
We like the name Digger. It just has the right sound, and I think it fits the bike.
The process of designing a motorcycle is a balance of art and science. At Harley's newly opened Product Development Center, another team was being assembled, a select group of engineers. It would be their job to turn styling's designs into a working motorcycle. The job of keeping the project on time and on budget was given to Harley's chief engineer of motorcycles, Pat Keller.
I was excited because this was a chance to do something really new and meaningful for Harley-Davidson, and I was really looking forward to a chance to make some history with this project.
Jeff Romanesco, who had spent the last 6 years engineering Harley's touring bikes, was put in charge of the team that would build the P4's chassis.
To be able to take a clean sheet of paper and develop a whole new motorcycle is just incredible.
Working with him was a small group of engineers who were sworn to keep the project secret, even from their families. At this point, no one could begin to fathom the energy or the man-hours it would take over the next 6 years to create this new Harley.
Putting a VR 1000 race engine into a street chassis meant that it was going to have to be quite a bit different from a traditional Harley.
One of the first challenges was understanding what has to be involved to make a Harley-Davidson a Harley-Davidson. You know, how far can we take this clean sheet approach?
Their first step was to put a VR 1000 racing engine into the frame of a traditional Harley.
So the styling department came and took a look at it, and then after about 5 minutes, and we had spent weeks building it, after about 5 minutes said, "This looks like a Softail with a liquid-cooled engine in it. That's not what we want. Start over."
It really told us very strongly what not to do.
The traditional look of a Harley was not intended for that engine. That's kind of where we started to talk about, well, you know, we need to do something completely different.
Appearances aside, there was also a practical problem. The traditional Harley frame wasn't sturdy enough to handle the considerably more powerful engine.
We knew the bike was going to be fast and powerful, and we knew the frame had to be very strong and very stable for that to work.
Jeff Romanesco assigned the job of designing the new frame to second-generation Harley engineer Rob Dennert, who had started with the company as a summer intern 12 years earlier.
This motorcycle would be capable of speeds much higher than anything we were building today. So we needed the structure that would allow handling at those speeds.
It also needed to look like a Harley.
We wanted the frame to be simple, direct. We wanted the frame to enhance the engine.
Willie G once said to me, I want something that I could hang up on the wall in and of itself and let it be a piece of art. That was a real challenge for us because frames are something that you attach things to, that provide structure, that connect the front wheel to the rear wheel. We had to do all those things and make it look good at the same time.
After weeks of CAD drawings, Dennert hit upon a solution, an elegantly curved double rail. In a traditional Harley, a single frame rail is hidden beneath the gas tank. To accommodate the additional horsepower, the P4 would have two rails that would run along the outside of the bike. As a bonus, Willie G and his styling team loved the idea.
We decided we would just take advantage of that and try to make the frame a part of the styling.
The only question was, could it be built?
And there really are no straight or curved sections that are defined by typical lines and arcs. For engineers, we like nice straight sections. Adding a curve or a shape to it complicates the mix. In order to get this kind of shape, we're going to need a tubing process that we don't use on our current frames.
The problem was that steel tubes can only be bent so far. Complex curves require welding separate pieces together, which makes for a weaker frame.
We were outside the tube bending manual at that point in time.
While the engineers struggled to find a way to avoid bending the frame tubes to their breaking point, they also began to ask a more basic question. How well would their emerging design work on a real live bike?
After the styling concept kind of got gelled, we knew what we wanted to do with the frame. We said, you know, we need to take that basic concept, put it into steel, and actually run the motorcycle.
A crude version of the frame was welded together in Harley's machine shop and married up with a VR1000 engine to become the new bike's first working prototype.
Do you think we really need two fasteners there?
I bet one.
Are you worried about it pivoting on there? Or I suppose you had the tab anyway.
To get the dragster look that styling was asking for, they wanted to see how far they could push out the front end. On a motorcycle, the more raked out the front end is, the harder it is to handle. To get the best of both worlds, they offset the angle between the steering head and the front fork.
That gave us the long, low, raked out front end look of the dragster custom motorcycle and still gave us the handling characteristics we need to be able to live with it every day.
The prototype brought them face to face with other issues. To make room for the engine's two large throttle valves, the fuel tank had to move. The challenge for engineering was, if the fuel tank couldn't go where it usually went, then where do you put it?
By doing some competitive analysis on other bikes and brainstorming sessions, we realized that we could put the fuel under the seat.
This created a new problem. With a big engine and a low frame, there wasn't much room left for a gas tank.
We had essentially a dragster fuel tank that we had purchased just out of a catalog. It held 1 gallon of fuel.
Another issue was a piece of gear no Harley had ever had to contend with before, a radiator.
We used a VR1000 radiator, packaged that on the front in any way we could to get some air to it.
Great. It's going to be interesting to see what we actually end up with.
This should be full extension, so I think we'll be okay.
We should be all right.
With cobbled together exhaust pipes and jerry-rigged wiring, it wasn't pretty, but the first incarnation of Harley's groundbreaking motorcycle was ready for its maiden voyage. It happened one quiet weekday afternoon way out in the country at Jeff Romanesco's house.
There weren't very many homes, and I knew nobody would be home at the time. And we cooked out some brats and rode a motorcycle in the afternoon. It wasn't a refined machine, but you could tell the potential.
The prototype had one undeniable quality. It was fast.
It had just an incredible rush. Almost had to be paying attention to make sure you hang on so you didn't get blown off the back of the things.
The red car. Oh, almost
It was pretty euphoric. We knew that this was going to be something special.
To power its new top-secret high-performance motorcycle codenamed P4, Harley-Davidson wanted to make a street version of the liquid-cooled engine used in its VR1000 Superbike. This would prove to be easier said than done. Jeff Coughlin was part of the engineering team assigned the daunting task of pulling it off.
The race engine is nearly wide open throttle all the time. You're pushing the limits, so you have very light components. You only need it to last 400 miles to get you through that weekend.
Race engines also aren't required to meet U.S. emissions and noise standards, and they're expensive.
A race engine can cost anywhere from $40,000 to $100,000.
To help turn the VR1000 into an engine that lasted longer than a weekend, ran well at street-legal speeds, and was considerably less expensive, Harley turned to one of the world's great engine makers, Porsche.
We gained the additional expertise to supplement our own. So there are more smart people looking at how to make the best product possible.
Porsche's engineering services facility in Weissach, Germany is renowned for its performance engine designs. In late 1996, a team from Harley took up residence there to begin collaborating on the P4. Meanwhile, back in Milwaukee, Willie G. and his team of stylists began working on what the new engine should look like.
The Harley imagery has always been a very strong V-twin.
There's never any question that from this company, the engine's going to be a styled masterpiece.
I've always thought of them as jewelry from a visual standpoint and shape. I think that works quite well. And also, it's very obviously a V-twin.
They began by making a clay model of what they wanted the new engine to look like. One purely stylistic touch that they added were air fins.
What we're doing is playing with fins, whether we want to bring them all the way down. What we try to do is look at the drag bikes, those big jugs.
One of their biggest issues was where to put the water hose.
The difficult issue in this one was how are we going to get the water out of there? The cleanest technical solution was taking that water straight forward towards the radiator, and that would mean crossing over a cylinder at the base, and that was not a good visual. It really was not. It is coming right in front of a part of the engine that we spent time making look good.
Their solution was to reroute the hose, taking it up and over the top of the engine.
It just seemed a crime to not split that thing in a symmetrical way. And I think we maybe gave engineering a couple of fits on that one.
And one of the things I like to tell the engineers when they griped about that is it's not the destination, it's the journey.
To get a sense of what the entire bike would look like, Frank Savage built a full-scale model using a fiberglass frame, a couple of tires, and a whole lot of modeling clay.
The speed at which you can create things in clay is analogous to the sketching on paper, the way I look at it. You throw down clay, you put down some lines. If you don't like it, you change it that quick, We can have critiques and change things in a heartbeat with clay. It can just happen like that. Okay, next concept.
The 3D model shed a glaring light on one of the bike's toughest challenges, the exhaust pipes, a job assigned to engineer Mike Nixdorf.
We need to talk with the tube bender. I think some of the radii that we came up with there are tighter than we've ever done before.
Tight radii, and you've got some very minimal straight sections there too.
The problem was that to meet noise regulations, it would have to be large enough to hold 12 liters of air, the biggest exhaust ever on a Harley. In engineering's initial blueprints, it looked both mammoth and ugly.
Man, those mufflers look huge.
Styling wasn't happy with the fact that we had to package 12 liters for one thing. But soon when they got over that, they knew that with that size, it had to be the best looking, sexiest exhaust system that we had ever put on a bike.
I think styling's going to have the last say on that no matter what we do.
The design of the exhaust came from a sketch that Kirk did. Kirk was doing some swoop and really playing around with quick shapes and gestures, and from there, we got this sketch. I'm like, oh, that's cool, let's try that. So I go to the clay and just start whittling away at it, and soon we're looking at that in 3D versus the two-dimensional thing and realizing, okay, these things are pretty big.
But how in the world are we going to make this transition? I mean, you guys have it so that the pipes are coming around, and then just, we've got nothing there. We looked at that design, and immediately it would strike fear in the heart of any engineer. Because looking at the clay model, it was beautiful. It just didn't look producible.
As one engineer put it, it was like trying to fit 10 pounds in a 5-pound bag.
Just remember that exhaust is such a big visual.
Yeah, I know.
We got 3 or 4 feet of tubing, and that will really be a big identifier on this right side of the bike.
But the biggest challenge that faced styling and engineering was just beginning: the radiator.
We've never had a big piece of real estate hanging on our down tubes.
Everybody was concerned about the radiator, and I think it was one of Willie's biggest concerns with the vehicle. We don't have radiators, we never had radiators, what are we gonna do?
We didn't want to just hang a radiator in the front of the motorcycle because everybody else does that.
They had to come up with a way to package the radiator so that it got enough air to cool the engine and also looked great. The task of coming up with the initial design was turned over to engineer Joe Schaffer and CAD designer John Myers.
It had to be styled into a Harley-Davidson, which meant that it had to be integrated into the vehicle. Being able to do that and still having a cooling system that was, fully functional, had lots of airflow and could cool the engine were quite a challenge to get past. I don't think we're going to get the airflow we need through the core. We're going to have to get outside further. Can we just make it a little bit wider? And the center we might as well not even have open in my mind.
See, I'm thinking styling's going to have heartburn on that because I'm already an inch wider than they wanted.
Real early on, we thought maybe the best way to make it as inconspicuous as possible.
The idea was to have it look like it's a piece of the bodywork on the motorcycle, but like there's not a radiator there. Literally hide the cooling system.
The first one we did was tiny. We loved that.
A prototype of the radiator was tested in a wind tunnel to see if it got enough airflow to cool the engine.
We discovered it flat didn't work.
It was a validation of the fact that we just didn't have enough airflow to cool the vehicle.
Part of the problem was the front tire.
The front tire actually acts as an air dam, so as the motorcycle is moving, all the air that hits the front of the front tire kind of gets shot around to the outside.
The engineer suggested making the radiator bigger and adding scoops to pull in air from either side of the front wheel.
Yeah, I know. Engineers like big radiators out in the open and with lots of airflow to them.
And they come up and say, what do you think about this? And it's got these scoops that are like this and real geometric. And we said, it looks like Gumby's casket. I don't know. It didn't look good. It was just these boxes of cereal out there grabbing air. So what we did was we started compromising. How far can we pull this back? Where can we trim it?
Like this?
Right, and follow that contour.
How about the bottom?
The bottom, if you could bring it down and come more off of this.
Kind of even with this?
Right.
But I'm coming back saying, no, it's got to be wider, it's got to be bigger. I don't care if it looks the way it does, just make it bigger.
And we'd try everything. And people would come in here, vice presidents would come in the styling department and look at it and just say no. And then we'd just be, okay, next version.
There are times when we would challenge them that there was just no changing the laws of physics, and there were times that they had to remain adamant because there was no changing the laws of Willie.
Two years into the project, the designers and engineers on Harley's top-secret new motorcycle had succeeded in creating the overall look of the bike. The battle now was in the details. Engineer Mike Nixdorf took on the challenge of more than tripling the size of the prototype's 1-gallon gas tank.
You can create a bike that looks awesome, but if you're only going to be able to run 50 miles on a tank, nobody's going to buy it. Are you still, now, on the shielding side, are you still thinking of having something on the tank itself?
They wanted at least 3.5 gallons, but the tight space left no room for a traditional steel tank of that size. Nixdorf suggested they try plastic.
Plastic fuel tank and Harley don't typically go together.
But plastic had its advantages. It was heat resistant. Being nearly seamless, it was more durable. And because it could be molded into every available nook and cranny, it could hold almost 4 gallons of gas. Meanwhile, the styling team was kicking around another idea that Harley had never tried before: aluminum.
They recommended that we do the sheet metal, fenders and airbox cover, out of wrought aluminum.
I'm not sure about these debossed sections. I think it could be simplified.
Okay.
I really like the side elevation because it's low in dimension this way and it has a lot of length. We wanted a finish that would enhance the performance look. When you think of aluminum, you think of Ferraris, you think of racing vehicles.
It's also a material that I think, when combined with chrome, has this beauty and simplicity.
Aluminum is a wonderful material. It's lightweight, it's corrosive resistant and so forth, but it's very difficult to form into compound shapes.
Frequently, when you go down some path like that is going to be difficult, the reward at the end is going to be that much greater.
Part of the appeal of a Harley has always been the ability to customize it, to make it uniquely your own, and the V-Rod was no exception. Early on in its development, another group of Harley designers focused on creating parts and accessories that would fit the bike's highly styled look without appearing to be an afterthought.
In the case of the windshield, they really want it to appear that it's just floating in space, that it's just there. If you look at it from a profile view, all you see is the slim edge, and that's it. You can barely tell it's on the vehicle.
A bigger challenge was designing a saddlebag that didn't compromise the bike's lean, stripped-down look.
One of the design challenges for the bags was there's no overhang for the lid to open properly. Our engineers came up with this 4-bar linkage hinge. When the saddlebag, if you're looking at it from the side, it actually lifts the lid off first and then pivots it forward.
The biggest holdup now was unfortunately the most critical part of all, the heart of any Harley, the engine. When the first prototype finally arrived, it was put into the latest mock-up of the bike so it could be road tested for durability.
The very first running prototype engines that we saw were somewhat disappointing. Designing a motorcycle is much different than designing a car. For example, the acceleration rates that this motorcycle has are much higher.
Despite these setbacks, Harley remained confident in the joint team's ability to tackle the roadblocks ahead.
So there was a strong effort from both companies to reinforce the team. We got a lot of Porsche's best experts assigned to the project, and we got a lot of involvement from Harley-Davidson, and together we completely redesigned the engine from that point.
And as you take 2 steps forward and all of a sudden 1 back and sometimes 2 back, you know, your heart starts to pitter a little bit all the time. And how much more money is this going to take? How much more time is this going to take?
The P4 was taking far longer than anyone had expected. But for every setback came a success. For one, the engineering team found a way to make a frame that had both the elegant curve styling wanted and the durability that the new engine demanded.
We've eliminated the weld marks and the tool marks and things like that because it is now one piece. We're actually making some pretty good progress. I had been doing some research around different ways to fabricate materials, and I came across an article around hydroforming.
Hydroforming is a process that uses water pressure to bend and shape sections of pipe from the inside.
What it does is it literally expands the material like a balloon to form out and fill out the cavity to represent the shape.
It allowed them to reduce the number of welds from 17 to 7.
And it really gave styling that jewel that they could hang on the wall.
An equally ingenious solution was finally found for making a big exhaust look small.
With two mufflers in the stylized shape that styling had asked for, there's no way that we were going to be able to form essentially an S-bent shape. It was physically impossible. So we came up with the idea of a third volume.
The two pipes coming out from the engine feed into a single chamber, the so-called third volume, creating a cleverly concealed extra space.
This third volume served as the chamber where we flow 2 into 1 into 2.
One stumbling block that remained was getting the notorious radiator cover, nicknamed Gumby's casket, to both look good and to work. Without good air circulation, the engine would overheat. In wind tunnel tests, they found they could get air flowing to the radiator, they just couldn't keep it.
Once we had these big air scoops, we could get them to grab air, but the air would go in one side and out the other. And
a breakthrough finally came using an air scoop made out of a most unlikely material, a Federal Express box.
one of the professors at the wind tunnel introduced us to the idea of putting some vortex generators into the backside of the cover.
A vortex generator is a fancy name for a fin that stirs up the air.
So we just took cardboard and taped these little vanes.
And when we did that, it created a turbulence in there that allowed more air to flow through the system and really improved the performance.
At Porsche in Germany, the engine team was finally on a roll. A new prototype delivered in early 1998 was put into the latest mock-up of the bike. The engineers decided to put it to the ultimate challenge, Willie G's first ride.
The true signature of whether or not this is a Harley-Davidson is Willie Davidson. Willie's first ride, as I recall, he was one of only 2 or 3 vice presidents that day that were able to ride the bike because, quite frankly, Willie broke the bike.
I laugh now, maybe it wasn't so funny that day, but it was a prototype, and there were some parts in there that were handmade, and I managed to lock it in 4th gear and had to bring it in, but I got to ride it, and I had a big smile from ear to ear.
Even though he had broken the thing, when he exclaimed that this is an expletive Harley-Davidson, we knew that we were onto something.
The challenge now was making an engine that would hold up for the long run. As a benchmark to shoot for, the joint engineering team suggested the infamous Dusseldorf test. The test simulated a grueling trip from Porsche's facility in Weissach to Dusseldorf along Germany's notorious high-speed Autobahn.
It would get all elements of city speeds, of climbing hills, of going through corners, good straight Autobahn stretches of unlimited speed.
The folklore is if you can survive that test, you can survive any test.
Because it was impractical to monitor the test on the actual roads, it was run on an engine simulator called a dynamometer. To pass, the engines had to endure an obstacle course of wide-open throttle and mountain climbing torque. The goal was 500 hours, nearly 21 days non-stop.
It probably got to about 50 hours before we started seeing some issues.
Because it wasn't a car engine, some suggested that a lower number might be more realistic.
You could argue that maybe this was too aggressive. And you could say, okay, 400 hours is fine. We made it that far, but we did not. We said 500 hours.
For well over a year, one engine after another was pushed to the breaking point. The joint engineering team learned from each setback, made improvements, then tried again. Their tenacity paid off. In March 2000, an engine passed the 400-hour point and was still running.
People were calling on 20-minute intervals, are we there yet, are we there yet? We're getting very close, we're getting very close. We're all got to have our fingers crossed.
The engine that got off to such a difficult start was now exceeding everyone's wildest expectations, cranking out 115 horsepower and revving at over 9,000 RPMs. With a top speed of over 140 miles per hour, it would be Harley's fastest, most powerful engine ever. It was so innovative, they decided to call it the Revolution. But there was still one small hurdle to clear: parades.
This is also Harley-Davidson, and if it's a Harley, it's got to withstand parade duty.
A problem that remained at that point was keeping the vehicle cool in idling conditions.
The tightly packaged engine left little room for a large cooling fan, so engineers tried two strategically placed smaller fans. To put them to the test, they headed to the hottest spot they could find. At the Arizona Proving Ground, daytime temperatures can easily hit 120 degrees. To test the bike's ability to stay cool at idle, they're first taken on a 50-minute warm-up ride around the 5-mile track. Once they're warmed up, they're rolled into something called a heat shed.
The ambient temperature has to be a minimum of about 100 degrees. And then the vehicle is driven into a shed, which is nothing more than 4 walls and an open roof, and it's closed with the hot sun coming down on the vehicle, and the vehicle has to be able to idle for a period of time without either shutting down or overheating.
When the time is up, the bikes are taken out and ridden for another hour in the blazing heat, then put back in the shed. This goes on all day. To everyone's relief, the bikes ran for 8 hours without overheating once. The Revolution engine had passed. After nearly 4 years of design and engineering, prototypes of Harley's top-secret performance bike had to face their toughest challenge yet: months of real-life durability tests. To guard against unauthorized publicity on the work-in-progress bike, the distinctive aluminum bodies were spray-painted flat black.
Even if someone did get a photo, it was going to be difficult for them to really make out the shapes.
The bikes were ridden as much as 80,000 miles in a variety of conditions to test which parts held up and which parts didn't. After each 8-hour shift, the riders got to give their opinions about what they liked and what they didn't.
We will test for engine noise, engine vibration, suspension, seating position, headlights, mirror positioning, brakes, acceleration. You name it, we run it through its paces.
In addition to straight track, the bikes were also run several thousand miles on the grueling bump course.
The point of us running that is to try to put as much damage into that vehicle in the shortest amount of time as possible. It shakes us, the bike, but we find failures out there that you wouldn't find anywhere else.
To test for road conditions that are harder to find in real life, another group of prototype bikes were sent to Harley's test labs in Milwaukee. The reverb chamber is a copper-lined room used to bombard the bike with a barrage of radio waves.
The test simulates the environment you might see outside: CB radios, AM and FM radios, cellular phones, anything that uses radio waves.
The idea is to test for every kind of electronic interference. Antennas shoot out waves that bounce off the copper walls. A rotating fan stirs the radiation into a full-scale bombardment.
Sort of like a big microwave oven. We often joke that we could pop more popcorn here than anyone else if we wanted to.
Each bike then spent a day in the hogwash. For 24 hours straight, 30 high-pressure jets of water blasted the bike from every direction, just to see if anything leaked or shorted out.
What we're looking to find out is the water intrusion into the vehicle, the speedometers, into tour packs, saddlebags, any place that you wouldn't want the water to be.
After the rinse cycle, the first thing they checked was, would it run? Next up, bike parts were pounded, twisted, and shaken in Harley's structures lab for weeks on end.
The purpose of the structures lab is to make sure that the components that go on a motorcycle are not going to fail in service. You want to figure out what it takes to actually break it, and then you also want to figure out how long it'll live with a normal input. So you're looking for the weak link.
The full vehicle simulator puts the bike on a bone-jarring hell ride over a simulated road course that includes endless bumps, potholes, and torn-up pavement. It goes on non-stop for 5 days. Parts were also tested for how well they held up against the elements.
The entire concept of the vehicle is very much metallic. We had to figure out how to make it stay that way for as long as somebody owned a motorcycle.
Test chambers subjected parts to endless pea soup fog and saltwater air. Several lucky parts got to spend a few years catching rays up on the roof of one of Harley's plants to see how they handled blistering sun and acid rain. But the real test of a Harley is what it sounds like.
We go into a lot of trouble to protect the sound of the motorcycle because Harley has a legendary sound. People talk about the sound of our bikes.
The bike's sound was fine-tuned in Harley's anechoic chamber.
Anechoic stands for a room without echoes. In the room, we have a robotic system that takes an array of microphones around the bike. When we're trying to understand where a noise is coming from, a little whistle or a little ting, we can create this holographic field around the bike and zoom in right to where the noise is coming from. Right away, you can start zoning in on things that just don't sound Harley. Covers that talk a little more than they should, gears that may whine a little more than they should. Those are the first things we address.
They also had to make sure the bike could pass new, increasingly tough noise regulations around the world.
Throughout the planet, they have different regulations that call for an accelerated test. The track outside is a regulatory test track, and we find the loudest sound pressure level, and that's the number that's reported. It's really for making sure that the comfort of the people around you isn't disturbed.
As the bike neared completion, Willie G's son Bill Davidson and other members of Harley's marketing department struggled with one of the biggest challenges of all, what to call it.
We had literally hundreds of names.
Oh, this one, toaster. Toaster. You're riding a toaster.
I'm riding a toaster.
I'm not sure that one works.
It actually took us over a year.
Full belly VRC, I don't think we like that one.
No. The minute you find one you like, you find out that it's trademarked in Japan. We had one name we liked and found out it was the name of a toilet bowl cleaner in Europe. So we said, okay, that one can't work.
The key element was having a name that when you saw this name, you could see this bike. So the two were locked together.
And after coming up with a lot of names and whittling it down, the one that kind of kept coming up that people really started to gravitate toward was V-Rod.
V for the V-twin engine, VR for the VR1000, Rod for its dragster, hot rod style. With everything finally in place, it was time to gear up the assembly line. Both the engine and the bike itself would be put together at Harley's newest plant in Kansas City. At the head of the new V-Rod assembly line will be the world's first fully automated pipe-cutting robot. Using cameras for eyes, it could recognize whatever length pipe it was given, cut it with a precision laser, then do its own quality check of the end result. The successful partnership with Porsche continued. The Revolution engine would be built as a joint venture in the same plant as the rest of the bike. Though the V-Rod wouldn't go into full production until after the dealer show, the assembly line had to be put through its paces. Setting up for mass production and adapting to an assembly line created new challenges for Harley. Because of the lean, low design of the bike, it proved difficult to fit the engine into the frame. The solution? 2 removable rails that would also make it easier to service the bike. It began as a simple idea. Now, almost 6 years later, after hundreds of unexpected hurdles and hard-won breakthroughs, after thousands of hours of both disappointment and success, after millions of dollars invested in a melding of art and science, the V-Rod was finally a reality. The official launch of the V-Rod was scheduled for the annual Harley-Davidson dealer meeting held this year at the Los Angeles Convention Center. For the team of engineers and designers, this was it. They had set out to build a bike that was unlike anything Harley had ever made, but that was also unmistakably a Harley. To respect a great American tradition, but also to grow and extend that tradition into the future.
It's been an emotional journey that I will never forget. The fact that we have been able to execute a product that is this much different than everything else we've done is again a testimony to this organization. I will always be proud of that.
Later this year, there's going to be a bike out there that I had something to do with every single part, and I don't know how I'm going to react.
When you actually get on the bike and ride, it makes you so proud to know that this is something that we created from scratch. I mean, without us, this product would not be here.
When you work together this long and this hard with this much passion, you never forget it.
It's been 5 years now, roughly 5 years. So we're walking by it, we're looking at it, and we're taking it for granted to some degree. And to see other people's responses to it is going to be phenomenal.
When they take that cover off at the dealer show, I guarantee you that I'm gonna have to turn away a little bit.
Why is that?
Well, you're a Harley guy. Nobody can see you cry.
It's really fantastic to be standing here knowing that a new Harley Classic is just about to be sprung on the world, and we did it.
You know, I've spent half my professional career at Harley working on this, and here it is. We're finally going to get to show it. We're finally going to get to talk about it. It's almost hard to describe. We're going to shock the world. This is it.
It's going to be awesome.
Ladies and gentlemen, let's give a rousing welcome to Willie G. and Bill Davidson and the newest member of our family, the Harley-Davidson V-Rod.
I think it's awesome.
It's definitely a Harley.
It's gonna rock the motorcycle world.
Man, I just can't believe it. It's true. It's breathtaking.